and the observation or data is on the horizontal line. Next, the frequency of a data, example scores, is equal to the area of each bar. So make note of these information as you pause the video and follow each of them. Now here's an example. Now remember, we had asked you now to do this example before I show you what to do. So pause the video, use the notes to guide you in constructing the histogram for this example. Now the frequency table shows the number of points gained by the teams in a series of cricket matches. So here are the points, and here's the frequency for each point gained. Now here's the question. How many teams took part in the series? The answer is 31 teams. Now how I got that? Now if 3 teams got 0, then you will have 3. 1, 2, 3. Then we add. So basically what we have done is add up all the numbers in the frequency column to get our total number of teams that took part in the series. The 31 teams were a part of the series. Good. So therefore, the total frequency is equal to the total number of teams participated in the series. Now, draw a histogram to represent the data. Now here is your task. Now note, did you get something looking like this? Now remember that 3 teams, so first of all, note, the frequency is on the vertical side of the graph, and then the scores is on the horizontal side of the graph. So make note to that. So once you follow that first step, then you'd have gotten 1 mark so far in designing your histogram. So we place the frequency on this side and the scores on this side. Now note, how many teams got 3 got 0 points? 3 teams. Good. How many teams got 1 point? 2 teams. And how many teams got 2? None. So of course that's why you have a space right there. So that would have been 0. How many teams got 3 points? 5. How many teams got 4 points? 6. How many teams got 5 points? 7. And how many teams got 6 points? 2. See? It's 2. How many teams got 7 points? It's what? 1 team. And how many got 8 points? 0. How many got 9 points? That would have been 4 teams. And how many got 10 points? And that would have been 1 team. So this would have been your histogram. If you had done this on your graph leaf, then your answer would be correct. Now, we're going to find a probability of that same question. If a team is chosen at random, calculate the probability that it gained less than 5 points, exactly 5 points, at least 5 points. Remember that the probability is equal to the frequency divided by the total frequency. Okay, now you can pause your video and try it for yourself, and then let us see if we have the same answer. Okay, probability for less than 5 points. Step 1. Calculate the number of teams who got less than 5 points. So here we have, first we look for the 5 points, but less than 5 points would have been 4, 3, 2, 1, 0. So we want to find then the number of teams who got less than 5 points. Now the first thing then, so our second step then was to identify the points that are less than 5. So the frequency, so this 3 right here is the frequency or the number of teams who got what? Who got 0 points. Then the 2 is the number of teams that got what? 1 point. Then the 0 is representing the number of teams that did not get 2 points. And the 5 represents the number of teams that got 3 points. And the 6 now represents the number of teams that got 4 points. So notice now, what we have done is to add up the frequencies right here for the to get the number of teams that get lost that got less than 5 points. Good. And our answer therefore is 16. So once again, if you were to put out all the points there and count how many teams got less than 5 points, then you'd have counted 16 teams. Step number 2. Now you're going to now take this 16 and divide it by the total number of teams, which is 31. So therefore, the probability for to find the teams that got, for one team getting less than 5 points is 0.52. Simply. So you're doing the same thing that you were taught in the last example. Now we're going to find a probability for exactly 5 points. A team that will get exactly 5 points. Now note the word exactly. And note the 5 points. So you notice I circled the word exactly and then I circled the 5 points in the table. Then I identified how many teams got 5 points, and just 7 teams that got 5 points. So write down how many teams got 5 points. Good. So the number of teams who got 5 points is equal to 7. So that is step 1. Now step 2 is to divide the number of teams that got 5 points by the total number of teams, and then our probability will simply be 0.23. So simple. So all you got to do is first identify the points given right here, then the number of teams who got that 5 points, and then divide that number by the total number of teams that got the 5 points, and then your answer would be 0.23. Very easy. So we're going to part 3. Now find the probability for at least 5 points. How many teams will get at least 5 points? Now remember that the word at least here means that they can get 5 points or more. So step 1. Calculate the total number. This symbol means number. Calculate the total number of teams who got 5 points and more. So you must include the 5 points and then the other points that are greater than 5. So here it is now. So that is a 5. Very good. So notice this now. So this 5 points, this 5 points is in the column of number of what? Points. Very good. And then you identify now the frequency of persons who got more, who got 5 points or what? More. So here it is. So these are the points. So 5 is included because it says at least. So when you say at least, the 5 must be a part of it. And then the rest of it now, which could be 5 points or more. So 6 is greater than 5, 7 is greater than 5, 8 is more than 5, 9 is more than 5, and 10 is more than 5. So if it says at least 5, it means you include 5 and then you also include the numbers or the points that are greater than 5. Good? No. So 7 persons got 5, 2 got 6, 1 got 7, none got 8, 4 got 9, and 1 got 10. There it is. So we're going to add all these numbers here. 7 plus 2 plus 1 plus 0 plus 4 plus 1. So note, what you need to do is you realize that 7 teams got 5, 2 got 6, 1 got 7, no team got 8 points, 4 team got 9 points, 1 team got 10 points. So all you have to do is add all the frequencies right there. And then 7 plus 2 is 9, plus 1, 10, plus 4, 14, plus 1 is equal to 15. So these arrows are indicating to you where you start to add and where you stop. So you start to add from 7 down to 1. So step 2 now, we are going to find the probability now. So the same 15 here, which is the total frequency what of the data that they are speaking about, which is at least 5 points or more, is equal to 15, and then the total number of teams is what? 31. So we divide that 15, which is this 15 here, by 31, and then our answer will be what? 0.48. So therefore, all we do is to carry out the same steps throughout when finding the probability. So here we are going to look at another try this question. The table below shows the number of children per family in the families of the pupils in a class. A. Draw a histogram to represent the data given. And B. If a family is chosen at random, calculate the probability that the number of children in the family is part 1 less than 3, part 2 more than 3, and part 3 exactly 3. So pause your video now and try this question. Answers. Now your histogram should look something like this. Okay, so you would put the frequency here and you put the number of children per family. Very good. And then part B should be 0.2, part 2 of B is 0.5, and part 3 is 0.3. So therefore 1 should be in the center here. Then you have 2 in the center, then 4, 3 in the center, then 9, 4 in the center right here, then 5, 5 here, then 5 in the center, then 7, 6 in the center, and then 2, and then 7 in the center, and then 1. So you could pause the video and match your graph paper to my answers and see if you had the right thing. Well, another try this question. Number 2. The data shown below are the maximum temperatures recorded in degrees Celsius on 25 consecutive days in one of the Caribbean islands. Construct a frequency table to organize the data above. Using the frequency table, draw a histogram to illustrate the data. Answers. Now here we have the frequency table for the first part of your answer. So if you had this frequency table, then your answer would be correct. And here now we have our histogram. So put frequency on this side and the maximum temperatures on the horizontal line. So you should have 27 in the center, 3 here, 28, 5 there, 29, 3 there, and 30. You have the 5, 31 to 3, and 32 to 6. So those are your answers for this try this question. Okay, now we're going to look at frequency table with group data. So what we have been looking at before was a frequency table or frequency distribution table with ungroup data. So now we are going to look at a frequency table with group data. In the real world, many persons are given jobs to collect information from many persons in various places using questionnaires with short questions. When you are to tally these data, it takes a lot of time with such large data. So therefore, persons find it wise to group the data in classes to enhance the concept group data. Example number 1. The marks of 50 candidates in an examination for which the maximum was 100 are given below. So here are the marks. Can you imagine? 50 candidates and the maximum was 100. So what you could do now is to write all this down and make sure that we have 50 different numbers right here. Okay, so we're going to now construct our frequency table for group data. Now we're first and foremost, we're going to count the number of persons who got marks from 0 to 9. So you can pause the video and try to figure out the frequency for the number of persons who got 0 to 9, number of persons who got 10 to 19, number of persons who got 20 to 29, number of persons who got 30 to 39, etc. Good? Alright. So pause the video and try that now. One person got 6, 3, 7, 4, 5, 6, 8, and 9. So how many persons got from 0 to 9? That will be 1, 2, 3, 4, 5, 6, 7, 8. So 8 persons got from 0 to 9. Now how many persons got from 10 to 19? That's 1, that's 2, that's 3, that's 4, and that's 5. So 5 persons got from 10 to 19. Hope you're following me now. 20 to 19 now. That's 1, that's 2, that's 3, that's 4, that's 5. Okay, so 5 persons got from 20 to 29. Now how many persons scored between from 30 marks to 39 marks? That's 1, that's 2, that's 3, that's 4, that's 5, that's 6, that's 7, That's 8. That's 9. That's 10. That's 11. That's 12. And that's 13. The 13 persons scored from 30 to 39. How many persons scored from 40 to 49? That's 1. That's 2. That's 3. That's 4. That's 5. That's 6. And that's 7. So 7 persons scored from 40 to 49. How many persons scored from 50 to 59? That's 1. That's 2. That's 3. That's 4. And that's 5. So 5 persons scored from 50 to 59. Now how many persons scored from 60 to 69? That's 1. That's 2. That's 3. That's 4. And that's 5. So 5 persons scored from 60 to 69. Now how many persons scored from 70 to 79? That's 1. And that's 2. So only 2 persons scored from 70 to 79. And of course, no one scored from 80 to 89 and from 90 to 99. Very good. Did you get this? So if you got this, you're on the right track. Good. So your total frequency should be equal to 50. Notice now that what they did, they grouped the persons who scored between 0 to 9, between 10 to 19. So that is what we call group data. So we group the information from one number to a next. Good. Ungroup is if we just dealt with the numbers by itself. Alright? Very good. Now, let's continue. Some terms you need to know, like class interval, class limits, class boundaries, class midpoint, width of a class interval, or class size. Okay, so we're going to look at class interval. And here's our definition. A class interval is defined as a grouping of statistical data. For example, as you can see, we have from 0 to 9. So in other words, we are grouping the marks from 0 to 9. And the number of students or candidates who scored from 0 to 9 marks were 8 persons. So this 8 means that they are 8 students who got marks from 0 to 9. Okay, now we're going to look at class limit. Class limits. The class limits are the end values of a class interval. Each class interval has 2 class limits, a lower class limit to the left and an upper class limit to the right. So remember now that a class interval has 2 class limits, a lower class limit and a upper class limit. For example, 60 would be our what? Lower class limit. And 69 would be our upper class limit. So as you can see now that a class interval has 2 n values, good, and each class interval has what? 2 class limits, an upper class limit and a lower class limit. So just remember now, once again, That is 60 is our lower class limit. And that is to the what? Left. And then our upper class limit is 69, and that is to the right. Next, class boundaries. Note, to get the upper and lower class boundaries, we do the following. We subtract 0.5 from the lower and add 0.5 to the upper class limits. And that is how you get the upper class and lower class boundaries. For example, here you have class interval, lower class limit, upper class limit. So to get the lower class boundary, we subtract 0.5 from 60 and you'll get 59.5. So 59.5 would be your lower class boundary. Now 69 is our what? Upper class limit. And to get our upper class boundary, you'll add 0.5 and you'll get 69.5. Very good. So what do we mean by boundary? In other words, you cannot go lower than 59.5, neither can you go higher than 69.5. So everything would fall between these two boundaries. Very good. So here is your class boundaries. 59.5, which is your lower class boundary, and 69.5, which is your upper class boundary. I'm going to ask you now to take one of the other classes and make up a question for yourself and find the class boundaries. Class midpoint. The midpoint of a class interval is the average of the lower and upper boundaries of the class. So in other words, to find the class midpoint, you must first find the what? Upper and lower class boundaries. Sometimes the midpoint represents the whole group. What I mean, in other words, instead of writing the class interval, you just write the what? Midpoint. The midpoint is also called the class midmark or class value. So once again, the midpoint of a class interval is the average of the lower and upper boundaries of the class. For example, once again, this is our class interval. So our lower class limit and our upper class limit. Our lower boundary was 59.5, and you know exactly how we got that, right? Good. And our upper boundary is 69.5, and I'm quite sure you knew how we got these two boundaries. So now we're going to find the midpoint. So what did we do? We add the lower class boundary to the upper class boundary, and then we divide that by 2. So you add both boundaries, then you divide by 2 to find the midpoint, which is 64.5. So that would be the midmark or the class value of that class itself. The width of a class interval. The width of a class interval or class size is the difference between the upper and lower boundaries. This means that we subtract the lower class boundary from the upper class boundary. I'm going to ask you now to pause the video, and then you're going to find the width of the class interval from 60 marks to 69 marks. So pause the video now and find the width of the class interval. Now here's our example. So we're using the class interval 60 to 69. So we said to subtract what? The lower class boundary from the upper class boundary to find what? To find the width of the class interval. So the width of the class interval is 10. And that's easy. Constructing a histogram using group data. Rules for a normal histogram are the same. So the same rules that you were using before with the histogram that we looked at before earlier in the lesson, we use the same rules. The only difference with the group data is that you would use the class midpoints on the horizontal axis or the class boundaries on the horizontal axis. So this is the only difference between the histogram for group data and the histogram for ungrouped data. Now we're going to go straight into our try this question. But before you do this try this question, make sure that you understood what was shown to you on the video clip. Okay, so here's our try this question. The table below shows the distribution of masses of 100 adults measured to the nearest kilogram. Part A, 50 to 9, which of the two numbers is the upper class limit? Part B, what is the class mark for this class? Part C, what is the class size for this class? And Part D, draw a histogram to illustrate the data in the frequency table. Answers. Here are our answers. For Part A, 59, for Part B, 54.5, and for Part C, 10. Look at the physical demonstration for the answer for Part D.
Alright, for to construct your histogram for Part D of the question, the first thing you'd have to do is to work out the class midpoints for each class. And then you'd place the class midpoints following the rules to construct an histogram, where you place the data at the center of the bar. So the bar will take up 2 centimeters right here, and at the center of the bar you would place the class midpoint for each class. Good? And then you place that on the horizontal axis, and then you write the name of the data, the title of the data, which is mass in kilograms, and we're using, of course, the class midpoints. Now on the vertical side, you make sure you use the frequency. Now we're going to use a scale of 1 centimeter for 5 units. Good? So 1 centimeter for 5 kilograms. Good? Or 5 masses, that is. So 1 centimeter for 5 masses. So 5, 10, 15, 20, 25, 30, 35. Good? Now 54.5 is the midpoint for the frequency 5. So therefore we're going to draw from here, and then you draw here, and that's your first bar graph. And remember, there's no space between the bar graphs for histogram. Now for 64.5, which is the midpoint for class 60 to 69, then that would be 9. So I count from 5, 6, 7, 8, 9. So each line is 1. So 5 is there, 6, 7, 8, 9. Then draw from that line all the way cross, and then down. Then now, for the next class, which is 74.5, it is 28. So I'll look for 28. So I find 25 right here. I count 26, 27, then 28, which is right here. Then I come all the way down. For the next class, which is 84.5, which is the midpoint for 80 to 89, it will be what? 33. So I look for 30, which is right here, in line right there, as you can see. In line, you can use your ruler to line it up. So this is 30, and I'm going to count 33 now. So 30, 31, 32, 33, which is right there. And I come across, then down. And then for the class now, which is 90 to 99, the midpoint is 94.5, and then that would be 17. So I can look for 15. I have 15 right there. You know, it's 2 lines above. So 15, 16, and 17 right here. So draw my line up. Then I have this. And then finally now, I have the midpoint for the class 100 to 109, which is 104.5, and then therefore that will be 8. So I have 5, which is right here, in line, as you can see. This 5 there, and I count 6, 7, 8. Okay, and I come down. So this is your answer for part D. Very good.
Alright, now we're going to look at drawing statistical diagrams. Statistical diagrams are used to illustrate statistical information and is easier to read and manipulate. Drawing a pie chart. So here we have a table illustrating the information, and we're looking at the subjects right here. We have mathematics, we have 17 teachers, for English 25 teachers, for physics 10 teachers, and for chemistry 15 teachers, and for history 23 teachers. So our first example is here. The table above gives the number of graduates by subject from a teacher's training college in 1992. For example, Michael, Churches, GC Foster College, and the other teachers college. Okay, so what they're saying is that they are recording how many teachers graduated in 1992 from maths, English, physics, chemistry, and history. Good, so 17 graduated for maths, 25 graduated for English, and 10 for physics, and so on. Example 1 continued. Part A. Calculate the total number of teachers that graduated from the training college in 1992. At this moment, I'm going to ask you to pause the video and do this calculation. Part B. Determine the sector angle that will represent the number of teachers graduating in each subject area. Once again, you pause the video and you attempt to do part B. Part C. Hence, construct a pie chart of radius 2.2 centimeter to represent the information given in the table above. Okay, now I'm going to show you how to do part A, B, and C, and then you can compare your answers with mine. Okay, part A. Calculate the total number of teachers that graduated from the training college in 1992. Now my question to you is simple this. How would you do this? Alright, so simply you're going to add number of teachers for maths, which is 17, to the number of teachers for English language, which is 25, number of teachers for physics, which is 10, and the number of teachers for chemistry, which is 15, and the same for history. And your answer should be equal to 90. So therefore, the total number of teachers that graduated from the training college in 1992 is 90. Part B. Determine the sector angle that will represent the number of teachers graduating in each subject area. Alright, the first step is to write for each subject, or let's just use maths as an example, and then you have your fraction bar. Then you write a total number of teachers, which is 90. So 17 teachers graduated from maths, but the total number of teachers who graduated is 90. So we're going to now multiply that by the angle for a circle, and that is what? 360 degrees. So in order to find the sector angle to represent the number of teachers who graduated in each subject area, you place the number of teachers for each subject area over the total number of teachers, and then you're going to multiply that by 360. So therefore, you can simply divide 360 by 90, and then you'll get what? 4, and then you use 4 to multiply by 17, and then your answer will be equal to 68 degrees. Now I'm going to ask you to do the same for English, physics, chemistry, and history. Okay, now we're at part C. Hence construct a pie chart of radius 2.2 centimeter to represent the information given in the table above. The angle for mathematics is 68 degrees. For English, 100 degrees. For physics, 40 degrees. For chemistry, 60 degrees. And for history, 92 degrees. Now, to determine whether or not your answers are correct, all you need to simply do is to add each angle, and if the answer is 360 degrees, then your answer would be correct. Now, I'm going to ask you please to pay close attention to the video clip so that you can learn exactly how to use these angles to construct your pie chart.
To construct the pie chart, our first step is to use a radius of 2.2 centimeters. So therefore, we're going to use a ruler and to draw a line 2.2 centimeters. So here's 1 centimeter, here's 2 centimeters. So 2 strokes after it will give me 2.2 centimeters. So that is my radius. Then now I'm going to take my compass. Then I'm going to open the compass according to the length of the line, and then I'm going to draw my circle. Easy as that. Good. Now I'm going to measure out the angles that we calculated for mathematics, English, physics, chemistry, and history. Now I'm going to start off with the smallest angle, which is 40 degrees for physics. Now in using your protractor, you're going to place this part of the protractor right here, the center of the protractor, on this point. Good? Just like this. So I place this point and cover this point. Now make sure now that this line of the protractor covers the line that you drew before. Now we're going to count from 0, which is from this 0 right here, all the way to 40 degrees. And sometimes it's best to use the point of your compass to make sure you do it accurately. So 0, 10, 20, 30, 40, which will be right here. Good? 40 degrees. I'm going to take my ruler again. Then I'm going to draw a straight line from that point all the way back to the center. Now I don't need all of the full length of the line, so I'm going to erase this. And here we have, so this will be for physics, 40 degrees. Now the next one is 60 degrees. I'm going to take the compass again, the protractor that is again, and place the point again on this point, and I'm going to place this line to cover this line. Good. Then I'm going to count 60 degrees this time. So it's 0, 10, 20, 30, 40, 50, 60. Now where the 60 line is, if you can see right here. Good. Line it up like that. And then draw my line from there. Then I'm going to rub this out because I don't need a full length. And then this now would be chemistry, which is 60 degrees. Then now I'm going to do mathematics, which is 68 degrees. So I do the same thing. Place the point on it. Then I count off my 68 degrees. So here's 60. Then 61, 62, 63, 64, 65, 66, 67, 68. So each small line I count as 1. Good. And then now I draw a line again from here to the center of my circle. And that is 68. Then I erase this. And then that would be for mathematics. Then now I'm going to need for history, which is 92. So take the same protractor again. I'm going to measure 92, and I rest it on this line once again. So make sure at all times that the center of the protractor is in the center of the circle. So I'm going to count 92. So here's 90 degrees right here, if you can see, 90 degrees right here. So 90, 91, then 92 right here. Good. And then you draw a line straight to the point, which is right there. So that is 92 degrees. And that will be for history. And you can rub this out. And that is that. So obviously now, what is remaining will be what? English language, which is 100 degrees. But it's always wise to measure to make sure it is accurate. So you place this on the center. Then you can use any of the two lines. And then count from 0. So place it on the center. Alright. Good. And here it is. So from 0 to 100. So you realize that this line is covering, the line of the protractor is actually covering this line right to the pencil line. And here you have 100. So therefore, this is 100 degrees. And that would be for English language. And that is how you construct the pie chart when you receive the angles or you are given a radius and they are given the angles, and then you just now use the angles to divide up the pie chart. So you'd use this pie chart now to represent your data.
Try this question. An estate valued at $60,000 is divided among three daughters, Annette, Betty, and Coral, in the ratio 1 to 2 to 3 respectively. Calculate the amount each received. And for part B, draw a pie chart to represent the shares of the three daughters. So pause your video now and try this question. Answer for part A, $10,000 for Annette, $20,000 for Betty, and $30,000 for Coral. And part B, this is how your pie chart should look like. So if you notice, half the amount went to Coral, and then the rest went to Annette and Betty. So once your angles are correct, then you should get this correct as well. Interpreting a pie chart. Now, here's is R. We have W here, which is 107 degrees, M 18 degrees, E 14 degrees, and T 53 degrees. I'm going to ask you now to draw this pie chart for me now. Okay. Now the pie chart illustrates how a manufacturing company spends its budget for a year on various items as indicated below. W, which stands for wages and salary, R, raw materials, T, transportation, E, electricity and telephone bills, and M, miscellaneous. The company spent $875,000 on electricity and telephone bills. Calculate A, the total budget, B, the amount spent on raw materials, C, the percentage of the budget spent on wages. So I'm going to ask you now to pause the video and try to do these three questions. All right. Note the following, that 360 degrees represents the total what? Budget. So here you have an entire circle. So your total budget is represented by 360 degrees. Now 14 degrees represents what? $875,000, which is the amount spent on electricity, which is E. Okay. Now, in order to find the total budget, what you simply have to do is to cross multiply, where you multiply 360 by the amount given for electricity, which is $875,000, and then that will be equal to $315 million, and then you're going to divide that amount by 14 degrees to get your answer for the question, which is 22,500,000. So first of all, if you are given an amount which is a part of the total budget, you simply multiply 360 by the amount given, and then whatever answer you have received for that, they're going to divide it by the angle given as well to get your answer. Now note, what if you had, say, $10? Good. And you were to share this $10 between, say, two persons, and one was supposed to get 2/5 of it, and then your answer then would be equal to 4. Now, this question could be given to you in a different way, where they gave you the 2/5 and they gave you the 4 and ask you to find the 10. For example, in our question we were given 14 and we know that the angle of a circle is 360 degrees. So right here now, this 2 would represent the 14 and the 5 would represent the 360 and the 4 would represent the $875,000. So you are given these information now to find the 10 would represent the $22.5 million or the $22,500,000. So the question is then, how do we use the number in this circle and the number in the circle to find the 10? Simple. What would you do? You would simply say 4 divided by 2/5. So you do the reverse, right? Good. And then as you know that 4, you change the sign and say multiply, invert 5/2, and then of course 4 times 5 is 20, divide by 2, and then your answer would be 10. So you can use this model to help you just in case you forgot how to carry out a calculation simple or similar to this rather. Good? Clear? Now here's another model that we could use. Now we have 2/4 times 500, which is equal to 250. Now try finding back the 500 using the 2 quarters and the 250. And I showed an example before. So that is a method now that you can use to help you when you're given a situation like this to solve. Alright, let's continue now. Okay, another concept. Line graph. Now a line graph is a graph constructed by joining a set of points together in a consecutive manner. The set of points represents known values of a given variable. For example, a girl's height was measured over several years and the data were recorded below. When you're given a table to construct a line graph, it is always best to analyze the table first. Okay, so let us look at the difference in height for the between ages 9 to 11, and that was what, 5 centimeter. What about the difference in height from ages 11 to 13? That would be what, 15 centimeters. So therefore she grew 15 centimeter more over 2 years. And then now between ages 13 and 15 she grew another what, 10 centimeter over another 2 years. And then from 15 to 17, this time she increased by 7.5 centimeter. And then basically 19 to 21 she stopped growing when she became what, 19, because it was a constant. Now notice once again that this growth took place over what, a 2-year periods. Now if you notice that she increased in height from 9 to 11 for 5 centimeters, and then from 11 to 13 that growth increased. So instead of 5 centimeters it was now what, 15 centimeters, and then it decided to what, reduce this time by what, so this time it was what, 10 centimeters, and then it continues to reduce. In other words, therefore she's basically going to her peak. So when she reached 19 now, she no longer continue to grow. So this young lady now, she stopped growing at what, age 19. Alright, so the first thing you need to do is to analyze this table first. Another observation that we can make which is the shortest, which period would have the shortest growth. Alright, and which period had the longest growth, and also which period you saw um, that everything was constant. So you can answer these questions while we are going through the rest of the lesson. Okay, now draw a line graph to represent the information given in the table above. Alright, I'm going to ask you to take out your graph paper and follow me as I show you how to set up your graph, your line graph. Now here I have a graph paper, okay? And I'm going to use the vertical side of the graph. I'm going to place the information for height, and also, just in case you forgot, that the information for frequency should also be placed on the vertical side of the graph. And then on the horizontal side of the graph now, you place the age, or what, time. So now we're going to number our graph. So we have 0, 30, 60, 90, 120, 150, and 160. Now the scale that we're using on the vertical side of the line of the graph itself is that for every 1 centimeter we have what? 10 units. So for every 1 centimeter, that will be equal to what? 10 units, or 10 centimeters rather. So from here to here is 10 centimeters. Now, the same scale I'm going to use now for the age. For every 1 centimeter, we'll have the age. So 9 years will go right here. 11 years will be here. 13 years. 15. 17. 19. And 21. Now we're going to plot our first point. When she was 9, she was actually 120 what? Centimeter. So this is where 9 is, along this line right here. So if you follow my point, I'm going all the way up this line here, and then I'm going to meet where 120 is, which is right here. So right here is where I place my first point. Good? Now, for 11, she became 125 what? Centimeter. Now note, for every centimeters, it's what? 10 centimeter. So to get 125, they will have to weigh half of what? 10. And half of 10 is 5. So half of this line will be 5 right here. So therefore, 120 plus 5 will give us 125. So our next point will be right here. Good? Now, when she was 13, she was now at what, 140 centimeters. So we identify where 13 is, which is this line. We go all the way up to 140. So if 150 is right here, then 10 centimeters below would have been 140, which is right here. Good. We're going to plot the next point now for when she was 15 years old. When she was 15 years old, it was what? 150. So we go all the way from 15 here to meet what? The 150 mark, which is right here. Come across right here. Good. She was 17 now. She became what? 157.5 centimeters. So if this is 150 right here, then this will be 155. So 2.5 more, which is half of what? 5 will be right here. Good. Then now, when she became 19, she was what now? 160 centimeters, all the way to the top, which is right here. right here. And then now, she remain at 160 2 years after, which will be right here. Good. Now after that, now after you plot all the points, you're simply going to connect each point using a straight line. Good. So that is your line graph. All right. Use the line graph to answer the following questions. Part 1. During which period did the girl's height increase the least? Part 2. During which period did the girl's height increase the most? And part 3. Locate and state the period when the girl's height was constant. Not the boys, but the girls. Okay, now we're going to use a graph to determine when the period to which the girl's height increased the least, the most, and when it was what? Constant. Now, it's very easy to do. You could simply take your ruler and measure the length of each line. And the line with the shortest length would have been the period through which, or where you'd find the girls increase the least. Now, you could also use your graph, your table, but they ask you to use the what? The line graph. Now, if you notice, from ages 9 to 11, she had only increased what? By 5 centimeters. Good. But if you looked at the one between 15 to 17, she had only increased by 7.5. So therefore, the one with the least would be what? Ages 9 to 11. So that should be your answer. Now with the most, another trick again that you could use is to what? Use your ruler and to measure the length of the line. And the one with the longest length will be the answer for part 2, which indicates in which period she had the most increase. And that would have been between ages 11 and 13, because she was 125 to 140, and that was an increase of 15 centimeters. Now constant means what? There's no change in what? Height. So at 19 she was what? 160, and over the next 2 years she remained the same height, which is also 160. So for the period through which the height was constant would have been 19 to 21. And that is how you'd use your line graph to answer questions such as that, or such as these rather. Now we have come to the end of this lesson, and it was created by Ronnie Bernard and recorded by Leighton. Thank you for viewing another one of
Go get your education, me a beg you to revise where you learn from class, me a tell you no. Cause it's not hard, it's a task, just give yourself a chance and you see that you grasp where them tell you no. Go get your education, me a beg you to revise where you learn from class, me a tell you no. Cause it's not hard, it's a task, just give yourself a chance and you see that you grasp where them tell you no. Now the machine a better, you go the dashing instead of you dip on the corner and I get your head machine. The little youths them nowadays, them need to learn, to love, to read and recognize, for you survive education and the key youth. From George's, KC and JC, Pally Camper down, Meadowbrook and Papine, Calabar and Dunwoodin, till pre the news about the pick up the two cause of the books so no fi read and so get your education, me a beg you to revise where you learn from class, me a tell you no. Cause it's not hard, it's a task, just give yourself a chance and you see that you grasp where them tell you no. Go get your education, me a beg you to revise where you learn from class, me a tell you no. Cause it's not hard, it's a task, just give yourself a chance and you see that you grasp where them tell you no.